What's going on, linear algebros? This is Mr. C here, and in this video we're going to do this problem where we are essentially forming the composition of two matrix transformations and looking for the standard matrix that would represent um, the resulting product of each individual standard matrix. So here in our example it says find the standard matrix for a rotation of 90 degrees. Okay, so that's a standard matrix that we'll have to think about, followed by a reflection about the line y equals x. So here what we want to do is figure out what this matrix is. Let's write capital T sub b, circle T sub a. And recall, if you were to use an input vector, let's say we wanted to multiply this by an input vector x, you want to think backwards here. This notation would tell us that first T sub a gets used, and then after that we use T sub b. Okay, now we don't have a particular vector x that we have to apply our standard matrix to, but it's helpful to think about, what would happen if we did have a vector x, because this helps us form the proper order of the matrices. Okay, now going back up to the instructions, there's this keyword or a keyed phrase here, followed by. So this means that the reflection about the line y equals x happens second, which means the rotation of 90 degrees happens first. Okay, so our matrix A should be associated with the rotation of 90 degrees, whereas our matrix B should be associated with the reflection about the line y equals x. Okay? So with that said, the matrix A, which is a rotation of 90 degrees, is going to use the rotation operator, capital R, sub 90 degrees. And you may recall the first column's entries go cosine theta, sine theta, so we want to do cosine of 90 degrees, sine of 90 degrees. And then the second column is going to be negative sine 90 degrees, cosine 90 degrees. Simplify each of the trig functions. Cosine of 90 is 0, sine of 90 is 1. Second column is going to be negative 1 and 0. The matrix B that we want to use is a standard matrix 2 by 2. Reflection about the line y equals x. The first row's entries are 0 and 1. Second row's entries are 1 and 0. So with that said, we're now in a position to form this standard matrix. Recall that that notation can be rewritten as capital T sub b, bracket, bracket T sub a. And in my last video, I said that this really just boils down to the product of the two matrices, and it would be that product B times A. So let's bring in the matrix B. And then our simplified version of the matrix A. And we'll form the product here. Okay, multiply the first row by the first column, we're looking at 1. Multiply the first row by the second column, we're looking at 0. 0 down here, and then negative 1 for the last entry of this matrix. So here's the thing about the matrix that we just constructed. Rather than, and I'm referencing this first part of the solution, rather than doing two different matrix multiplications with each input vector x, namely first multiplied by the matrix A, then multiplied by the matrix B, we can do some scratch work in advance to come up with the standard matrix when those two matrix transformations, standard matrices, are multiplied together. So basically, instead of doing two calculations with any given input vector x, we could just do one calculation because we've already formed the composition of the two standard matrices. So once you have this composition matrix formed, it really cuts down the amount of work that you would need to do when trying to transform vectors. It basically takes two matrices, forms them into one, so all you really have to do is one product versus two products. Alright, so hopefully that all makes sense. This is where we are done with the video. If you have any questions, let me know. Otherwise, I'll see you in the next one. Thank you.